Good morning to everyone. Today we are going to learn several topics regarding the thermodynamics. First of all, a scope and limitation of thermodynamics. That means what we can learn from the thermodynamics and what we cannot. Then intensive and extensive properties. Some properties, what are the actual property or internal property of the material, and then some other extensive properties. A state of a system. We have several systems and we will learn a state of a system. Then equilibrium and non-equilibrium states. The criteria for equilibrium, that means what condition need to be fulfilled or what conditions are followed in during equilibrium. And then different thermodynamic processes. We have several thermodynamic processes and we will learn some of them. And now let's start from the scope of thermodynamics. That means what we can learn or what the thermodynamics study. Most of the important laws of physical chemistry. That means in thermodynamics we have mainly three different laws. First law, second law, third law, like this way. And sometimes you may have heard about the fourth law or zeroth law, but we are not more interested on that one. So in thermodynamics we will focus on mainly the first law, second law and third law. But in this first semester course we will not go in the third law or second law, just we will try to focus on first law. So the most of the important laws of physical chemistry, including the Van 't Hoff's law of lowering of vapor pressure. Not only that, we have several other laws. The Van 't Hoff law and phase rule and the distribution law can be derived from the laws of thermodynamics. So most of the laws what are followed in physical chemistry can be studied or can be understood using the thermodynamics. It tells whether a particular physical or chemical change can occur under a given set of conditions. That means that is depending on thermodynamics or thermochemistry. We have mentioned in the first class or first lecture that we will learn different things in our this course, thermodynamics and thermochemistry. If the reaction can happen or not, how fast the reaction will be, these types of things we can learn about the thermodynamics. It tells whether a particular physical or chemical change can occur under a given set of conditions of temperature, pressure and concentration. That means if the temperature is feasible, that means if you want to have a change in the physical state from solid to liquid, in that case you need to change the state by, or you need to change the position of the atoms or molecules. How you can do that? You need to increase the temperature, and in that case the distance between the atoms or molecules will increase due to increase the kinetic energy. So that can be studied from the thermodynamics. It also helps in predicting how far a physical or chemical change can proceed. That means if you supply a certain amount of energy to a system, in that case if the energy is very high, in that case the reaction can proceed further distance or further time. But if you supply just a certain amount of energy which is not sufficient, so if you have some reaction with the maybe you are familiar with the reaction barrier. That means for any reaction, if you provide some energy, if the reaction can provide the energy, if the energy is more than the reaction barrier, the reaction can proceed. But if the provided energy is less than the barrier, in that case the reaction will not proceed at all. So you need to maintain certain condition, or if you fulfill the condition the reaction can proceed, or if you have more energy above the barrier, in that case the reaction can have further steps, or it can proceed for the long time, and if you do not provide sufficient energy, in that case the reaction will not happen or the change will not happen. Now we will see what are the limitations of thermodynamics. Everything, every idea or every knowledge what we learn, some of them have some limitations. Limitations, that means if you learn about the periodic law, in chemistry you have learned the periodic law, that means how the periodic table is organized. In that case, initially it has been thought that the periodic character of the elements in the periodic table changes with their atomic mass. That has been given by John Dalton. So, but we know that nowadays, if you consider the periodic law as the atomic mass, that is not the exact way. So it has some limitation. So after that, scientists have found that the periodic character do not follow the exactly atomic mass. It has some trend with the atomic mass. However, if you want to rearrange perfectly, if you follow the atomic mass technique, then you cannot rearrange all of them perfectly. So after that, scientists have found that if we rearrange the atoms or elements in the periodic table based on their atomic number, then it is even better. So the periodic character is still we have some difficulties. We cannot fix the position of hydrogen. Even today I have been teaching to the computer science students that about the boron. Boron is an element in the group 3 or group 13. However, the physical and chemical properties are very similar to silicon. That means it has some different in their physical and chemical properties, though they are in their atomic number. So these have their change in the atomic number. However, their physical and chemical properties do not match with the same group in the periodic table. However, this is also another limitation of the periodic table, even in the modern periodic table. So all of the idea what we are generating based on certain condition. So if you do not fulfill the condition, then it will not follow. So in that case, we will have some limitations. So thermodynamics is applicable to macroscopic systems. Macroscopic system, yesterday I have mentioned the macroscopic system. Macroscopic system means something which has a lot of number of molecules or particles in the system. That means if you want to understand the idea for a very particle size, that means quantum system. If you consider very small particle, and if you want to find out the thermodynamics, or if you want to explain the characteristics using thermodynamics, that cannot be explained, because the thermodynamics is applicable only for macroscopic system, that means for a bulk system, for a bigger system. So it ignores their internal structure of atoms and molecules. That means we do not consider the atomic structure in thermodynamics. We consider the bulk structure, bigger molecule or lot of molecules together. So thermodynamics cannot explain that way the very small particle or the interaction between atom and molecules, that cannot be described using the thermodynamics. Thermodynamics does not bother about the time factor. One thing, that means it do not have the thermodynamics do not study the reaction. The thermodynamics, that means not reaction, that means reaction rate of reaction. How we will learn about that? We will learn in the kinetics chapter. The thermodynamics and kinetics has two different terms. Thermodynamics do not have factor with the time. However, the kinetics, that means where we can study the rate of the reaction or the change in the reaction with time, the relation between the reaction rate with time, that can be studied using kinetics, not from the thermodynamics. So thermodynamics do not bother about the time factor. Now another term, intensive and extensive properties. What are the intensive and extensive properties? If some property which do not depend on the quantity of matter. If you have certain amount of substance, let us consider 1 gram of water or 1 kilogram of water. These two different amount of water, or 100 gram of water and 1 kilogram of water, that means 10 times different. So if you change the amount of the proper matter inside the system, then if the property changes, that will give you certain property that can be considered either intensive or extensive. Now let's see what we can consider. The property which does not depend on the quantity of matter present in the system is known as intensive. That means if the property do not depend on the quantity, that means 1 kg water or 100 gram of water, that if the property do not depend on the quantity of the matter inside the system is known as intensive property. Some examples of intensive properties are pressure, temperature, density. How we can consider that is a intensive property? So if you consider 1 liter of water, then what happens? Let us consider not the water, or even we can consider 1 liter of water having temperature 25 degrees Celsius. Now if you measure the temperature very small amount, or if you dip the thermometer just a little bit, you will measure the temperature 25 degrees Celsius, and if you measure the temperature of that water, even in the bottom of the water, you will measure the same temperature. So just the quantity or property, that property do not depend on the quantity of the matter. That means the very small amount of water, in that case if you consider the temperature of water is 25, in that case if you take a small amount of water that also have the temperature 25, and if you large amount of water that also have the temperature 25. So the property of that matter, that means the property of that substance do not depend on the quantity of the matter. So that is known as intensive property. And other way you can easily understand, if the property depends on the quantity of matter, that is known as extensive property. Just one other vice versa or opposite way, just if the property do not depend on the quantity, then it is called as intensive. Then if it is dependent, then we call extensive property. So if you can consider some of the examples of extensive properties are volume. Volume, that means if you take 100 milliliter of water in a container, then what is the volume? Then if you take 1 liter of water, then it has bigger volume or larger volume. In that case, that volume is an extensive property. So these types of property, if the property of a matter or substance do not depend on the quantity of the matter or the system, is known as intensive, and if the property depends on the quantity of matter is known as extensive property. State of a system. What is the state of a system? A thermodynamic system is said to be in a certain state when all its properties are fixed. That means if you want to define a matter or if you want to define a substance perfectly, you need to mention some properties like as temperature, pressure, volume, mass, composition, several other components. So if you want to define a substance perfectly, or if you want to mention the properties, then you need to define the specific, the fundamental properties which determine the state of a system are pressure, temperature, volume, mass and composition. you need to define that. If you want to have a 1 liter of kerosene, how you can define? You need to have the perfect volume. That means 1 liter volume, you need to take a container of 1 liter and then you can fill with the kerosene. Then you can tell that this is 1 liter of kerosene. So you need to mention the exact number or exact property. What is the property? Liter, volume. So volume is 1 liter. So you need to mention that the fundamental properties which determine the state of a system, that is in liquid state. But if you want to mention that is in gas, 1 liter kerosene in gaseous state, so that you need to mention the state, or you need to mention the temperature, at which temperature the liquid converted into gas, or what is the temperature of the gas. So since a change in the magnitude of such properties alters the state of the system. So if you change the temperature, pressure or volume, whatever, in that case the state of the system can be changed easily. So these are referred to as a state variables or state functions or thermodynamic parameters. There are several names of state of a system. So what are them? The state variables or state functions or thermodynamic parameters or the state of the system. There are 4 different names depending on when we are using or applying. It also starts to reason that a change of system from the initial state to the final state will be accompanied by change in the state variables. So if you want to move from one initial state to final state, you need to have to change the property from initial to final state to go from some other different states. Equilibrium and non-equilibrium. Equilibrium and non-equilibrium states, this is the states, not the chemical equilibrium. In case of chemical equilibrium, what you can understand easily, the rate of forward reaction and rate of backward reaction becomes equal. That state is known as the chemical equilibrium. But in case of equilibrium state, what we are going to learn in the thermodynamics, that is a system in which the state variables have constant values throughout the system. Let us consider this is a system and this is a frictionless piston. Frictionless piston, and if this is stationary, that means this is fixed. If you put the piston here, in that case the total molecules or total volume of that container will have more or less similar everywhere. The components will be same. It seems this portion little bit dark, however we are going to mention that everywhere the number of molecules or components are uniform. So a system in which the state variables have constant values. So state variables, what we can have here, temperature, pressure, volume. So if you fix the volume here and frictionless piston, if it is fixed, so stationary, so if you fix the position of the piston, in that case you can have the variables, all the variables have the constant value everywhere. If you consider the pressure of that cylinder in this position, if you want to measure the pressure here, you will get the same value. So the properties, a system in which the state variables have constant values throughout the system everywhere. If you measure the temperature here, if you measure the temperature here, everywhere it will give the same temperature. And if you have any other way, that means somewhere if the property of the variable or the state variables do not have the uniform distribution, in that case you can have some non-equilibrium system. So if you compress the piston, of this cylinder very fast, that means if you put some pressure to this piston and the piston going inside very fast. In that case, what will happen? This portion molecule have the more density, so the temperature and pressure can be changed here. And this portion, if you move very slowly, if you move this piston very slowly, in that case it will take very long time, so the molecules from this region can distribute everywhere with very long time, so it can have the uniform distribution, or it can be considered as in equilibrium. However, if you put the piston, if you move the piston very fast, in that case what will happen? The area, the region beside this piston or nearby the piston will have different properties or variable with different value compared to the position or region far away from the piston. So in this region you can have the properties of variables one value, and in this region you can have another value. So this situation is considered as non-equilibrium. So thermodynamic equilibrium, where all the thermodynamic properties or variables are same in the uniform in the system, or everywhere in the system are same. In that case you will consider that equilibrium, thermodynamic equilibrium. And if it is not in everywhere not same, or thermodynamic properties or thermodynamic variables are not same everywhere in the system, in that case you can consider this is non-equilibrium. What are the criteria for equilibrium? So we have learnt about here the chemical equilibrium or non-equilibrium. So I have mentioned that all the variables will be same everywhere. Here the variables will be different. So if you push the piston very slowly, that means long time process. If you push the piston very slowly, in that case the molecule will have a certain time, or molecule will have enough time to distribute everywhere, so that it can have the ability to distribute the variables everywhere, so it can have the similar variables everywhere, so it can be in equilibrium. Now what are the characteristics or criteria? The temperature of the system must be uniform and must be same as the temperature of the surroundings, thermal equilibrium. Here if you consider the system need to be in equilibrium, if you want to have a equilibrium system, what will happen? In that case the temperature of this system and outside the surroundings, the temperature of the system and surrounding will be different. So if you have the different temperature, in that case there will be some tendency to distribute the, if the temperature of these surroundings is different from inside, in that case what will, if the temperature of this system is very low, what will happen? The boundary will be get cold, so this boundary will be become cold. So if you have the temperature of this inside is very high and outside is very low, in that case there will be a tendency to get the molecules here nearby the surface of the boundary. So in that case there will be tendency to have the molecules even oddly distributed, not evenly, not equally, not homogeneously. So everywhere the system and surrounding need to be have the same temperature or the properties. So the temperature of the system must be uniform and must be same as the temperature of the surroundings. So system and surroundings need to have the same temperature, otherwise there will be some tendency to have the properties different. The mechanical properties must be uniform. The mechanical properties, that means we have different types of mechanical properties. That means that is not related to the chemical change. The mechanical properties must be uniform throughout the system. Mechanical equilibrium, that is no mechanical work is done by one part of the system on any other part of the system. So if there is any work done by the system mechanically, then that cannot be in equilibrium. So the mechanical properties must be uniform throughout the system, everywhere. The chemical composition, if you put sorry, the chemical composition should be same everywhere. If you have hydrogen here, if you have oxygen here, if you have nitrogen here, then the system cannot be in chemical equilibrium. So all the composition should be same in the system. So the chemical composition should be same everywhere. Okay, so all the chemical composition of the system must be uniform with no net chemical change. So with time there will be no chemical change. That means one component to another component, two chemical components reacting to give third component, that cannot be. So you need to have the system where if you put several gases, that should be unreactive gas. If you put two different gases which react each other, that cannot keep into chemical equilibrium, or that cannot have the thermodynamic equilibrium. So that should be kept non-reacting or inert gases, that can be considered as the chemical equilibrium, thermodynamic equilibrium. Now what are the thermodynamic processes? We have several processes. When a thermodynamic system changes from one state to another, the operation is called a process. That means if you have some state, or if you have a thermodynamic system, then you can change from one state to another state, and that is known as operation is known as process. So what types of process we can have? We have 5 different processes: isobaric, isothermal, adiabatic, isochloric, and cyclic. Here you can see 2 different figures, and we will discuss all the process using these figures. Isothermal, first let's see isothermal. What does it mean? Isothermal, that means if there is a system where the no change in the temperature. If you have a system where there is no change in the temperature, that is known as the isothermal process. If you have a system where the pressure has no change, that is known as isobaric process. If you have any process where the pressure has no change, that is known as isobaric process. If you have a system where the energy, where there is no change in the enthalpy or energy, is considered as adiabatic process. And where there is let's see everyone, isothermal process, the process in which the temperature remains fixed. For any process, if you have a process where the temperature remains fixed for a long time, now if you have a certain amount of gas, so if you have a isothermal process, your temperature is keeping fixed. If you fix the temperature, now if you want to change the system from one state to another, here you can see this process is isothermal process. But if you have a certain amount of gas, you can compress the gas, or you can increase the volume of the gas by keeping the process or keeping the temperature fixed. So in that case you need to change the pressure. If you want to compress, maybe you are familiar with the idea about the Joule-Thomson effect. Joule-Thomson effect, that is not directly related with the isothermal. However, in case of Joule-Thomson effect, we can we can decrease the temperature. That will not be the isothermal, but that will be related to the another term I will mention, that when what is the isothermal process, or I already have mentioned that if you have a process where the temperature remain fixed, this can be considered as isothermal process. But I am going to mention about the Joule-Thomson effect. What is the Joule-Thomson effect? If you have a very high pressure of gas, and then if you have a very small hole, and if you open the gas, that means if you have a very high pressure gas in one side and you are exploding the gas through a very small hole to a very large area, in that case what happens? The temperature falls. That means the temperature, if you make your mouth very big and if you throw a lot of gas together, in that case you can feel the air is very hot, like this way. If you put your mouth very big and if you throw a lot of gas, in that case you can feel the temperature of the gas is very hot, just like this way. You can, but if you make your mouth a very small hole, like this way, so if you put your mouth very small hole and if you put the pressure or if you put the gas very through a small hole and it is expanding in a very large area, in that case you can feel the temperature is very cold. So that is the Joule-Thomson effect. How? That means we are changing the temperature. We are changing the temperature of the gas. How? From very high pressure to very low pressure. Outside the pressure is very low. So when you put the when you put the gas from the mouth through a small hole, the outside pressure is very low compared to the pressure inside our mouth. So what is happening? We are changing the volume. So here you can see the volume is changing. So volume is expanding. If the volume is increasing, in that case what happens? The volume is increasing, so the pressure is decreasing. So if you increase the volume and pressure, decreasing the pressure, so what will happen? The temperature will fall. That is the Joule-Thomson effect. So we are going to mention 4 different processes: isothermal, adiabatic, isochloric, isobaric and cyclic process. So in case of adiabatic process, what happens? Those process in which no heat can flow through in or out of the system. That means there is no change in energy. So no energy is changed here. So if you put a process where there is no change in the energy or heat. Why we are mentioning heat? Heat is a form of energy. So we are mentioning as the process in which no heat can flow into or out of the system are called adiabatic process. For an adiabatic process, the dq or delta q equals 0, and here for isothermal process the delta t equal 0. Isobaric process, those process which takes place at constant pressure. That means if you have no change in the pressure, in that case what will happen? The delta P will be 0. Let's see, if you have a gas, certain amount of gas, and if you do not want to keep the change in pressure, so the pressure remains same. What will happen? So if you want to increase or decrease the temperature, in that case you need to increase or decrease the volume. So if you want to keep the pressure same, let us consider you have a small amount of gas in a balloon or in a cylinder. So if you want to keep the pressure always same, 1 atmosphere pressure, so if you want to increase the temperature or decrease the temperature, in that case what you need to do? You need to increase the volume. So if you want to increase the volume, so if you increase the temperature, you are increasing the temperature. So if you want to keep the pressure constant, in that case what will happen? So if you want to keep the pressure same, in that case increasing temperature will increase the volume. Otherwise what will happen? If you do not increase the volume, the temperature will increase the internal energy of the system and the pressure will increase. Therefore if you want to keep fix the pressure, and if you want to change the system from one state to another, then you need to change the volume. So the keeping the pressure fixed, you need to change the volume to change the system or to change the state of the system. So isochloric process, the process in which the volume remains constant. So isochloric, this term little bit different. Isochloric, so for every other term we have mentioned isobaric, isothermal, so that are related to the word. Thermal, that means temperature. Bar, that means related to the pressure. So isochloric is related to the process in which the volume remains constant, are known as isochloric process. So if you keep the volume of a system constant for a long time, in that case you need to change the pressure or temperature so that you can change the volume. For isochloric process, the delta V equal 0 or delta V equal constant. The cyclic process, what is the cyclic process? You are familiar with the cycle or different types of life cycle. So we start from one point, and after movement of several or after different steps, we come back to the original point. So that is known as the cyclic process. So for any system, if it has several steps and it come back after a certain period of time to the original point, that is known as cyclic process. When a system in a given state goes through a number of different processes and finally returns to its initial state, the overall process is called a cycle or cyclic process. For a cyclic process, delta E equals 0 and delta H equals 0. That means actually there is no work done inside, so the enthalpy change or entropy change are same. So here you can see this is a process. This process, if you start from here, then adiabatically you are increasing the volume, then isochlorically you are increasing the pressure, keeping the volume fixed. So you are raising the temperature. Now isobaric, now you are going back to the initial position by reducing the pressure. So by isobaric process, that means keeping the pressure same and reducing the volume. So first you are increasing the volume by adiabatic process, that means by increasing the by keeping the internal energy same. So that is the adiabatic process. And then if you want to increase the temperature, just keeping the volume fixed, which is known as isochloric process, and keeping the volume fixed and you are raising the temperature by increasing the pressure. So you are coming at this point and at last you are going back to the initial point. So overall this process is known as cyclic process. There are several steps or several process: isobaric, adiabatic, isochloric. This is a complex process. Here we have mentioned several processes, and here we are mentioning 3 different processes to come back to the original position. That is known as cyclic process. So this is the end of my today's class. So I'm not going to discuss you so many other process or reversible and irreversible process, and we have other different difference of reversible and irreversible process, and also I had something. So this is the end of today's class, and if you have any question or comment regarding this, you are welcome to ask.